Let's prove by contradiction that there is no greatest odd integer. To prove this statement, we first have to negate it. So in step 1, we assume that there is in fact a greatest odd integer, and let's call it n. Next, in step 2, we use some logic and known facts that will lead us to nonsense. In other words, in this step, we have to show that our initial assumption makes no sense. Okay? In other words, we have to find an integer that is both odd and greater than n. So what we can consider here, if we take our greatest odd integer n and add 2 to it, what happens? Well, this corresponds to adding an odd integer, because we assumed n is odd, to an even integer. And we know for a fact that the answer to this sum is an odd integer. If you pick any odd integer, let's say 7, and you add 2 to it, the answer is 9, which is odd. If you pick a different odd integer, 15, and you add 2 to it, you get 17, which is odd. Okay, so this is a known fact. If you take an odd integer and you add an even integer, the answer is odd integer. Okay, but what we also have here, well, n plus 2 is strictly greater than n. Okay, so by adding 2 to our greatest odd integer, n, we found another odd integer that is in fact greater than n. Okay, so we are pretty much done here. So what we do, we move on to step 3 and we conclude. Okay, so there exists an odd integer that is greater than n. N plus 2 is strictly greater than n, and it is odd. So this contradicts the assumption that the greatest odd integer is n. Okay, this in fact tells us that there is no greatest odd integer, so we've proved the original statement.